Hello everyone, welcome. For this tutorial, I'm going to go over make and makefile in Linux. Previously, I did a video on GCC and G++. If you haven't watched that video and you're not so familiar with GCC and G++ compiler, I will link the video on top. But if you are familiar with GCC and G++ compiler, you will know that it is very inefficient to use those two compilers by itself. So for example, in my folder, I have 4 files. Now, if I want to run this file to get a final executable, I will have to use G++-O, and I would have to give an output file. So I would say, for example, my output file would be grit, and then I would have to list all of these files that I have in my folder. So if I come here and I paste it, this will be my program. So if I go ahead and I hit enter, this will compile my program for me. If I do an XLS, I have my grit executable file here, so I can go ahead and say .grit, right? And it will print my program for me. Now, in the real world, this is not efficient at all. So we're going to start off with make. Make is just the command that you type into the command line. Make is not a compiler. GCC, G++, Clang, those are compilers. We use make to invoke a compiler. Okay? Make is an automation program that is used to automate your software application or to automate software building. The make utility will automatically determine which piece of a large program needs to be recompiled. So for example, let's say I have a program that has 3 files. So these are my 3 files. Now how make works, once I run the make command the first time, make is going to compile all 3 files. Now if I decide to change anything in happy.cpp, make will only recompile happy.cpp. It will not recompile happy2.cpp. It's not very efficient to recompile files that you have not made any changes to. So make will keep track of which file in your program in the current directory that you made changes to and only recompile that specific file. Okay, so I'm going to do a quick ls in my folder and I'm going to delete my output file grit. So I'm going to say rm grit, get this out of the way. I'm going to do an xls. And I am now remaining with these 4 files. So these are the 4 files I'm going to use for this demonstration for make. Okay, so if I go into grit.h, I just have 2 functions in here, greetings and greetings_2. Now inside of greetings.cpp, I gave definition to my greetings function that I have in grit.h. Then greetings_2.cpp. Inside this file, I define the greetings_2 function that I have in grit.h, and it just say hello from greetings2 file. And the last file is main.cpp. Instead of the main function, what I'm doing, I'm including the unistd.h, which is for my sleep function. And I also included grit.h because I want to use the greetings function and the greetings_2 function. Now, if you want to use make on your system, there are 2 ways you can install it. There are many more ways that you can install it. But for my system, if you want to install make, you use make install, and that will just install the make utility for you. Now, if you want to install GCC, G++, and the make utility, you can go ahead and write sudo apt install build-essential, and that will install GCC, G++, and the make utility for you. Now, to create a make file on your system, there are 3 ways you can name that file. So I can say VI, or if you want to create the file using touch, you can say touch makefile with uppercase M, or you can say makefile with lowercase m, or you can say GNU makefile. The make command look for any of those syntax in your folder or in your current working directory. So they either look for makefile with the uppercase M, makefile with the lowercase m, or GNU makefile. Now, preferably, I like to use uppercase M. And the reason why I like using the uppercase M, the makefile that's spelled with uppercase M will be the first file when I use the ls command. So I'm going to go ahead and hit enter. Now, if I do an ls, you would see that makefile is at the front. If I just say makefile with lowercase m, it will be somewhere around here together with the main.cpp. Now, and I say vi makefile. Inside of my makefile, I'm just going to write a simple target with a command. So I'm going to write this target called say hello. Automatically, once you start typing and you hit the colon, the text will turn blue. For me, maybe your system, it will be a different color, but the editor is smart enough to know that, okay, I'm writing code inside of a makefile. So it will automatically give you the syntax. When I hit enter, it's going to automatically give me a tab as well. So you see that? Now, how makefile works, when after you type your target and your prerequisite, which I'm going to explain in a bit, you must give a tab. So in here, I'm just going to give a command that says echo. For now, that's all I want in my makefile. So I'm going to go ahead and save it. Now, when I run the command make will run the echo statement inside of my makefile. So I'm going to go ahead and hit enter, and I get back hello all. I can also use make with an argument. So I can say make say hello, which is my target, and I still get back the same results. Now look at say hello. I'm going to go back into vi makefile, and this is my say hello target. So I'm going to do an ls. My makefile is right here. I'm going to delete that file. So I'm going to say rm makefile. I'm going to do another ls, and my makefile is gone. Now, if I do vi test, okay, and I go into test and I write the same target with the command. So I'm going to say hello, and I give a colon. Right away, you would see that the system is not picking up the syntax that it would for makefile. So I'm going to come down and follow the convention. I'm going to give a tab, and I'm simply going to say echo hello all. Now I'm going to save this, and I'm going to go back into the terminal and write the make command. And you see here it says make no target specified and no makefile found. So you must name the file makefile in order for it to work. Now I'm going to do an ls, and I want to remove the test file. So I'm just going to say rm test. If I do another ls, my test file is gone. Okay, so I'm going to clear my screen. Now with makefile is just a special text file, and that text file will contain shell commands or a set of rules that instruct make how to build your application. Okay, so the rules consist of 3 parts. You have the target, and the target is the name of a file to be created. So when you create a file, for example, if you use GCC or G++, your target file most of the time will be the a.out file or your output file. So target is the name of the file that you want to create. And that file is created once you execute the make command. Now, the dependencies, also known as the prerequisites, is the name of the file which you want to create that target from. Okay, so it's usually your program file. In my current directory, I have these 4 files. Now I want to create my target from these 3 files: greetings.cpp, greetings_2.cpp, and main.cpp. Okay, usually you do not compile the header file. So this is greet.h, and greet.h is my header file. You usually don't compile header files. These are the files you want make to use to create your target. And then when you come down, you must give a tab and the command. This can be command or this can be actions. Now, actions are actions like you guys may see it .phony or clean. So inside of your make file, you must have targets, you must have dependencies or prerequisites, and you must have commands. Now, the commands are rules describing how to create or update the target when dependencies change. So basically for my command, I'm saying when I make change to happy.cpp, I want you to run or update it with GCC or Clang or whichever compiler you're using. I want you to update it by running this command. Right? That's all the command does. The command is just rules describing how to create or update your target when dependencies change. Now, I'm going to go in here and create a makefile. So I'm going to say vi makefile, and inside of my makefile, now I want to create a target called greet.out. Now, for my target greet.out, I have to give it some dependencies. Okay, what should I create the greet.out with? So basically, I want to create greet.out with greetings.cpp. So that's one of the files that I have in my current directory. I also want to use greetings_2.cpp, and I also want to use main.cpp. Okay, so this is my target and this is my dependencies or prerequisites. Now I'm going to go down and hit enter, and it automatically gives me the tab. As I said before, you must give a tab when you get to the second line. After the tab, you're going to give some command that greet.out should follow. So I want to compile my files using G++. So I'm going to say G++. Then I'm going to list the files that I want to compile. So I want to compile greetings.cpp. I also want to compile greetings_2.cpp, and I also want to compile main.cpp. So these are my 3 files that I want greet.out to run and compile. And I'm using the G++ compiler. Now I'm going to create my own output file. So I'm going to say -o. I'm going to name my output file same as my target. So I'm going to say greet.out. I'm going to hit WQ to save and quit. So my program is it's a pretty simple program. I'm going to run the make command. Now when I run the make command, it's going to compile those 3 files for me. So I'm going to hit enter, and you can see here it's compiling my file using G++. So it printed out these lines for me. Now if I do an ls in my folder right now, I should have my greet.out file. So you see here, I just got my greet.out file. Now I can go ahead and remove that file and run that program or run that code again. So I can say rm greet.out is going to remove it. I'm going to do another ls. The greet.out file is not in my program or in my directory. So I'm going to run the make command again. It will run the G++ command. And then if I go back and say ls, it gives me a grid.out. So I can now run my grid.out file using /grid.out. It will print my program for me, or it will run my program for me. Let me clear my screen, and I'm going to go back into my makefile. Now, this way is not the most efficient way of writing grid.out. And the reason for that is if I make changes to, let's say, for example, greetings.cpp, right? Then greetings_2.cpp and main.cpp will also be recompiled as well. And we don't want that. So a better way to do this is to strip them apart. I'm going to delete this code, this command. So the best way to use makefile is to create some object files. I'm going to create my grid.out file, and for grid.out I'm going to give it some output file to look for. So the first output file going to be greetings.o, then greetings_2.o, and I also want a main.o. I'm going to come at the bottom and give some commands. So I'm going to say compile greetings.o, greetings_2.o, and main.o. And I want my output file same name as my target, so grid.out. So what I did here, this is my output file, grid.out, and these three files here is going to be my object file. So what's going to happen is grid.out now, just remember when you run in makefile, make automatically will compile the first target in your file. So what's going to happen is make is going to come, okay, I want to create a grid.out. What are my dependencies? So it's going to say greetings.o is my first dependency. It's going to come down and look for greetings.o. So that's when we're going to come in the bottom here and create greetings.o target with some dependency and command. Then once it runs that, it's going to go look for greetings_2.o. We're going to write the target with the prerequisite and the commands for greetings.2 and also for main. Let's go in the bottom and write the definition for greetings.o. For greetings.o, the dependency will be greetings.cpp. Okay, and I'm going to just say use G++ and compile this for me. So I'm going to say -c just mean compile greetings.cpp, and my output file will be greetings.o. I always make my output file the name of the target. So this is my definition for greetings.o. Now I'm going to come down and I'm going to create the definition for greetings_2.o, which is my object file. So I'm going to say greetings_2.o, and this file will depend on greetings_2.cpp, and the command I'm going to give for that is G++ -c greetings_2.cpp -o, and my output file will be the same as my target, so greetings_2.o. And then the last one is going to be my main.o. So I'm going to come down and say main.o, and I want main.cpp to be my dependency, and I'm going to run the G++ compiler. That's all I'm going to write in the makefile for now. This is a better way to write your makefile, because if I make changes to greetings.cpp, I only want this particular file to compile. I don't want all of this to compile. So I'm going to go ahead and save and quit. Go back to the terminal. Now I'm going to run the command make. So when I run make, if I have any errors, make is also going to tell me what my errors are. So I'm running the file. You can see here it created greetings.o, greetings_2.o, main.o. Now, if I do an ls inside of my directory, I will see all of my files that was just created. Greetings.o, greetings_2.o, and my main.o file is here. And I have my output file, greet.out. So all I have to do here now is just go in here and say greet.out. And I got back the result from my program. Let's run back the make command again. And it says that greet.out is up to date. That's because I did not make any changes to any of the file. Now, if I update any of my file or any of the files in my directory, then I can run the make command again. So if I do ls-lh and I come here, you would see that greet.out was updated at 107. Right now, let's go and update the timestamp for greetings.cpp file. So the easiest way to update any file on your system is by touching it, and touch will update the timestamp of the file. So I can go ahead and say touch greetings.cpp. Now, if I touch it and I do ls-lh, now you see my greetings.cpp now is at 110, right? It has been updated 110. Now, if I go back and run the make command again, you see here it updated only greetings.cpp. It did not update all of the files previously when I run the command the first time. It only updated the file that I make changes to, which is greetings.cpp. So let's go back into VI and we're going to say make file. Now, inside of the make file, we can write some action. So my action is going to be clean. So basically I'm saying when you execute those programs, once I run the clean command, I want you to delete all my object files that I have created. For actions, you don't need any dependencies. So I can come here and pass the command rm, and I want you to look for all of the files inside of my current directory with an O extension. So all of my output file that I've created above, I want you to delete them. And that's all that I need for my clean action. So I'm going to come here, hit escape, WQ to save and quit. Now I'm back to the terminal. I'm going to do a quick ls, and I still have my output files in here. Greetings.o, greetings_2.o, and my main.o file. Now I want make to remove those files. So I can come here and say make clean, and it run that command for me, rm*.o. Now, if I go back and I do ls, all of my output files are gone. So this is very important. Make sure you have a clean action in your make file to clean up your directories. You don't want a whole bunch of output files in your directory. Now let's look at variables. I'm going to go back into VI in my make file. And if you look at what's in the file, a lot of things are repeating. For example, I have G++ here, G++ here, G++ here, G++ here. So those are repeating. And in programming, if you know, you don't really want to repeat yourself or repeat codes or repeat commands, right? So that's why we're going to create a variable. And let's bring this down some more. So I'm going to come up here and create my variable. Some of the common variables you would see is CC for compiler, and with the CC you're just going to assign it a name of the compiler you want to use. For example, we're going to use G++. Now the reason why variables are very important, especially for compilers, let's say you want to move from G++ compiler to Clang or GCC or whichever compiler you want to use. You would have to go through all of this and change the compiler from G++ to Clang or G++ to GCC. which will be time consuming. So the best thing to do is to create a variable. We're going to call this variable CC. You can call this variable whatever you want to call it, but most developers use CC, or you could just say compiler. So instead of writing G++ for the compiler, you can just come here and say $. Then you're going to give the double braces, CC, and close off. And that's going to use the GCC compiler. So I'm going to do it here as well. CC, going to come down here, use $, here, CC, and the last one for main, I'm going to use $CC and close it off. So let's say, for example, my compiler now is G++. If I want to change it to GCC, all I have to do is just come up here and just change my compiler to GCC, and it will change all of the compilers for all of my object files for me. So I'm going to go ahead and hit escape, :WQ to save and quit. Now let's go back and run the make command again. You see here, it's using the G++ compiler. It's saying here main.o couldn't found. So maybe we deleted main.o by mistake. Let's go and check it. And yes, we did by mistake delete the o in the main.output file. So let's go back and put in the o, main.o, WQ to save and quit. And let's run the make command again for main.o. And you see here, it compiled only main.o for me because we deleted the o by mistake. So all of these files has been compiled beside main.o. So it just compiled main.o only for me. Now that I have my file ready, first I'm going to run the ls, and I have all of my output file here, including my great.out, and then I'm just going to say ./great.out, and I got back the results. Okay, we can do some more variables. I'm going to show some more variables for makefile. Now, if we look at the target file, great.out is the same name as my output file, or my output file is the same name as the target file. So what I can do, I can just say I want my output to be the same as my target, and all I have to write is $@, and that will create the output file for me, same name as my target file. So I can come here and I can delete this and use $@, and I'm going to come down to my main file. So in main as well, I'm going to use $@. So I can come here now and do escape, WQ to save and quit, and I'm going to clear my screen. So I'm going to run make clean to clean out the output file, and now I do not have any output file. I'm going to run the make command again, and you see here it created my output file greetings.o, greetings_2.o, and main.o for me. So if I come here and I say ls, you would see here my files have been created. So I created those files using $@ symbol. So if I come here and I run great.out, I will get the results of my program. Also, if we go back into VI, into our makefile program, we can also clean this up a little bit more. Now, let's say, for example, I want to change my dependencies from greetings.o to hello.o, and from greetings_2.o to hello_2.o. Then I would have to come here as well and change all of this. I can go ahead and clean this up by using a variable. Instead of saying my output file will be great.out, my output file will be $@, and then I'm going to delete all of my output files, and instead of listing all of my output file, I'm just going to say $ and the anchor brackets, or that little caret. So you have to press Shift and 6. That's what's on my keyboard, and that will replace or use the same names that is in my dependency or my prerequisite. So greetings.o, greetings underscore 2.o, and main.o will be saved in this little variable here, $caret. I can go down here and do the same thing. So I'm going to delete greetings.cpp, and I want to use the same name as my dependency, so $caret. I'm going to do this for the rest, $caret, and one more. Let's do it for main.cpp, $caret. Escape, WQ to save and quit, and go back to the terminal. Now I'm going to clear my screen and I'm going to do an ls. My object files are there. I'm going to run the make clean command to clean up my directory. Now if I do another ls, all my object files are gone. I'm also going to remove my grit.out file, and I'm going to create a new one just to show you that the variables work. Now I'm going to run the make command again, and you see here I got back everything that I did previously, and these are all just using the variables. Now if I do another ls, I got back all of my output files and my grit.out file. So I'm going to come here and run grit.out, and I get back the result as before. So that's how you use make and makefile. Now this is just the basics of make and makefile. There's a lot more you can do with make and makefile. I'm going to create another video how to use makefile with a more advanced technique. So that's it for this video. I hoped you did learn something from this video. If you did, please don't forget to like, subscribe, and share, and I will see you in the next video.